Swayam Prabha. Digital India. Educated India.
We have seen the substitution theorem where an element can be replaced by a voltage source or current source, and the value of the voltage source or current source should be exactly same as the voltage or current that was present in the element. That is, the voltage source value should be equal to the voltage across the element, or the current source value should be equal to the current through the element. Okay, so that's the substitution theorem. Now, it always works this way, right? You can substitute any element with a voltage source whose value equals the voltage across the element, and similarly with the current source. Now, the back substitution is also sometimes possible. That is, you can take a voltage source and substitute that with a resistor, for instance. That is very much possible. Okay. Now, the only condition is that for this to happen, you should have the voltage source to be dissipating power. Okay. So, if the voltage source is generating power and you replace that by a resistor, first of all, that resistance will have to be negative, and it does not always work. Okay. But if you have a voltage source which is dissipating power or a current source which is dissipating power, substituting that with a resistor, it will always work. Okay. And let us see what that substitution should be. This is also substitution theorem, but we can call it the back substitution theorem. And let us say I have a current source I with a certain V across it. Then what I am saying is that this can be replaced by a resistor. Okay. Now, what should be the value of the resistor? Let us say the voltage across the resistor is VR and the current through the resistor is IR. And we want VR and IR to be exactly the same as V and I. Okay. So, we want to substitute this current source with a resistor without altering any voltage or current in the circuit. So, VR must be V and IR must be I. Okay. We also know that the resistance R is VR divided by IR, which has to be equal to V by I. So, if I have a current source with a voltage V across it, I can replace that with a resistor where the resistance value equals V divided by I. Okay. So, this is how you can find the value of the resistance. Now, the one condition is that this resistance has to be positive. Okay. So, this is a sufficient condition. It turns out that if you substitute current sources which are dissipating power with positive resistors, the substitution always works, meaning none of the voltages and currents in the circuit will be altered. Okay. Now, the other way around, when the current source is generating power which corresponds to an equivalent negative resistance, that sometimes works, but for now we will just restrict that. Okay. So, if you go and replace every independent source in the circuit with positive or negative resistors, it will not work because of some other conditions. We will not go into that here. Okay. Now, quickly we can deal with the other case as well, where I have a circuit with some voltage source V, and let us say this voltage source V happens to have a current I through it. I say that the voltage source V can be substituted by a resistor. Now, what should this resistor be? Again, we want the voltage across the resistor VR to be exactly the same as V, and the current through the resistor IR to be exactly the same as I. So, VR equals V and IR equals I. Okay. So, the resistance value which is VR by IR has to be equal to V by I. So, when I substitute a voltage source with a resistor, I have to substitute with a resistance whose value is V by I, where V is the value of the voltage source and I is the current through the voltage source with the appropriate sign convention. the passive sign convention. Okay. And again, we will say that this has to be done only if R is greater than 0. So, that means that only if the original voltage source was dissipating power. Okay. So, that is also a variant of the substitution theorem, and sometimes it is useful to come up with circuits where if you end up with too many current sources, you can replace some of them with resistors.